Hey everyone, this week we will be going over the statistic that I've been asked about the most, and if you follow me on Twitter, you would have been able to see this, as during the MLB draft, I was posting some advanced stats, including weighted runs created plus. So, weighted runs created plus is that one where you're comparing against your league and the park that you play in. So I'll just read straight off of Fangraphs, and again, support them if you haven't already. Weighted runs created plus is a rate statistic which attempts to credit the hitter for the value of each outcome, single, double, etc., rather than treating all hits or times on base equally, while also controlling for park effects and the run environment. wRC plus is scaled so that league average is 100 each year, and every point or below 100 is equal to 1 percentage point or better or worse than league average. This makes wRC plus a better representation of offensive value than batting average, RBI, OPS, or WOBA. So this is what we're going to be calculating, essentially weighted runs above average divided by plate appearances plus the league runs per plate appearance plus the league runs per plate appearance minus park factor times the league runs per plate appearance divided by the AL or NL wRC over PA excluding pitchers. But really we're going to be using the wRC over PA for each conference that we're looking into. So let's get right into it. So to get started, we will be loading in 3 different packages in our library. And then I also have it under a comment to install these packages. So if you haven't already, DevTools install _GitHub Bill Petty Baseball R, which will allow us to scrape the college teams. And then library baseball R, as we call it, into our library. And then install.packages tidyverse, install.packages rvest. So we will be able to call all 3 of those into our library. So what essentially you do to install them is you remove this comment here, and then you'll just run that line as normal. So something as this, so I'll just call library baseball R, library tidyverse, and library rvest. So we'll get started. So again, I'll have a couple files on my GitHub page, which is in the link in the description below, where you can get these CSV files that I'm about to load. So what essentially we'll do is we'll call a data frame of a CSV. So we'll say guts. And that's essentially getting those constants that we need to calculate weighted runs created plus. So guts read.csv, which is from the base package, and we'll say NCAA guts underscore d1.csv strings as factors equals false. Piping operator indicator code, and we'll use a dplyr function called rename, and we'll just rename league WOBA to just, or we'll rename WOBA to league WOBA, so that way you can be able to calculate not only WOBA, which is a function of weighted runs created plus, but you can actually use it compared to the league WOBA, which is a calculation in the weighted runs above average, which I also did a video for both of those things as well. And then we will say mutate at underscore vars, and we'll say year, and then comma as character. So we're converting that year from an integer to a character. So we'll run this. I'll show you it real quick. So that's essentially what it looks like. We have the league WOBA, WOBA scale, the linear weights. Again, if you watch my WOBA video, you'll know what this is. And then runs for PA, which is what we need to calculate weighted runs created plus. So what we're going to do next is we're going to subset a specific 4 schools, all in the same conference. We're going to focus on the ACC for this video. So one way to look up school IDs, which is useful for the Bill Petty's Baseball R package function called NCAA scrape, which allows you to scrape their hitting data and pitching data. So one way to do it is a school ID lookup, and then in parentheses you'll say a school. So in this case we'll say North Carolina. And now we have their school ID of 457. So we have the school IDs of North Carolina, Wake Forest, I believe, is one of them, Clemson, and Florida State. So one quick way to get these different schools without having to run NCAA scrape repetitively is we'll say schools equals combine. So we'll combine these 4 IDs, piping operator, and we'll say map. Map is part of the per package, which is under tidyverse. And what we'll do is we'll say map function x, which essentially you're just saying you're creating your own function, space, and then we'll use that Bill Petty NCAA scrape. So NCAA scrape, we'll say x again, and the year is 2020, and we'll assume this type is batting. So it's already set as batting, so we don't have to do that again. So what this does, it goes through each of these 4 IDs in this function x and puts in those IDs for that CAA scrape function. So we run this, give it a second or two to load. It takes a lot less time than running a for loop. Now it's done. Great. Now we can say, I'll call this ACC. And we'll say bind rows schools. And now we can look into our data frame and see North Carolina, Florida State, Clemson, Georgia Tech. So not Wake Forest, but Georgia Tech. So the 4 schools that we're going to look at to get their data. And you can see from pulling that, you get their games played, games started, batting average, OBP, slugging, so on and so forth. But what we're going to go into next is clean some code up a little bit, or clean some columns, and then be able to merge this data together and then be able to calculate weighted runs created plus. So one thing that you may have noticed when you went through the ACC data frame was that there's no intentional walk data, and that's fine because for many previous years, I think that 2020 is the first year they actually had intentionally walk data on the batting side, but what I did for you to make it easier is I just created a CSV file that contains that IBB data for those players. So we'll call it by just calling IBB read.csv IBB data.csv strings as factors equals false. So we'll run this. And then we'll do a left join from the dplyr package, which is under tidyverse. So what we'll do is we'll call ACC, we'll say equals left join ACC, and then the Y is IBB by, and then that C means combine, and we'll combine player, school, and conference. So that way it merges by those 3 specific columns. So that way there's no duplicates. I could have done player URLs, but because the season was cut short, there was not player URLs for every player. So this is the other way of doing it. So boom, we got it. So what we'll do now is I will paste some code for you so you can see kind of what we're doing here. So what we're going to do is we're going to say ACC equals ACC. We're going to call that data frame. We're going to do a piping operator. We're going to filter at bats is greater than 0, games played is greater than 0. So that way we can get rid of unnecessary guys, maybe pitchers that were on the team, or get rid of team totals or opponents totals. So that way we can get rid of guys who did not have a plate appearance and guys who did not play a game. And then from the tidyr package, which is under tidyverse, we'll say replaced NA. And how we do that is we'll say list, and then we'll list the variables. So in this case, we have walks, hit by pitches, intentional walks, doubles, triples, home runs, hits, sacrifice flies, and sacrifice hits. We replace those as 0, so that way when we do our calculations for WOBA, weighted runs above average, and wRC plus, it won't come up as NA, so that way we can properly get the data. And then we'll do a mutate, which mutate just means add a new column. And we'll say PA for plate appearances equals at bats plus walks plus hit by pitches plus sacrifice hits plus sacrifice flies. So I'm going to run that. What we're going to do next is now we're going to combine that guts data that we loaded in with the ACC data. So a quick way of doing that is simply say ACC equals left join. So we're going to take that ACC data frame and join it with the guts data frame. So left join, ACC is your X, guts is your Y. Well, by equals combine year, and division. So that way we get the proper adjustment. So we'll go into it. Again, it's filtered for guys who at least had one plate appearance this season. And then it also has intentional walk data as well as plate appearances, as well as league WOBA scale, the linear weights for each event, and then runs per plate appearance. So one way to look at this now is we're going to now get the park effects of each school. So I'm just going to copy and paste this and just change it slightly. So I'll say PFs, which is just short for park effects, and we'll say get NCAA park factor, which was added to the baseball R package not too long ago, and we'll say combine 2016 to 2020. So we'll get the last 5 years of each of these schools. Just make sure that when you get however many years, try to get 5 as the optimal number, but sometimes parks don't allow that. So think of Kentucky's new field, UConn's new field if it were to be played this season, Oklahoma State's new field. They would have like a 1-year park effect, because if you use more than 1 year, you'd be using their previous field, and that would just skew the park effects data, and that wouldn't be correct. So just make sure that you do your research and make sure that you see, okay, which parks have been around for X amount of time. So we're going to run this function. It's simply get NCAA park factor, again, X, combine the years 2016 to 2020, and then we'll add that last parenthesis. We'll run this, and it just says acquiring game data and calculating park factors. Please be patient. And it shouldn't take too long. Again, depends on your machine. Again, better to use the map function rather than using a for loop using I. So it's already gone through one team. Now it's going through another team. That way we get that park effects data, and then we can say down here, while that's loading, we can say PFs equals bind rows, PFs, piping operator, select school, and then final park effect. And that way we can have that data readily available. And then as well as that, we can do another left join and say ACC left join, ACC, PFs, and then we'll say by equals school. So no combine, because we're just combining that school. So it should be done any second now. And now it just gives you a warning message. It says NAs introduced by coercion. That's fine. And now we can combine those two together, and let's look in our data frame. So these are the last 5 years. So something like North Carolina, their 5-year park effects were 0.993, which essentially means that it was North Carolina's field was slightly pitcher friendly. Florida State's field was slightly hitter friendly over these 5 years. Clemson, so Doug Kingsmore Stadium, they were just a tad hitter friendly. I mean, you would probably better say neutral after rounding. And Georgia Tech's field is 1.032, which means they're 3% hitter friendly. So now let's get into the calculation. So now, as you can see, there's already some code written, but part of it is from earlier videos. So make sure you do watch the WOBA video and the weighted runs above average video to make sure that you understand the formula and how that works on that end. So what we're going to do now is we're going to calculate weighted runs graded plus, which uses WOBA and weighted runs above average. So we're going to start by adding 4 parentheses, and we'll start by saying weighted runs above average divided by PA. So the weighted runs above average over the amount of plate appearances a player had plus the league runs per plate appearance, which I believe is 1.39. Say plus, add another parentheses, runs per plate appearance minus, and we'll say final PF, which is our park factor, times runs per plate appearance. And also the park factor is adjusted for the league that you play in. the base park factors that are generated do adjust for the conference that the team plays in. So the ACC conference, a very well-respected conference in baseball. So then we're going to divide by, in the formula it said AL or NL weighted runs created per plate appearance. Now that's really just separating by conference. So in this case, the ACC. So it's the ACC weighted runs created per plate appearance. But there's if you look at the weighted runs created formula, if you go back to the website that I showed you at the beginning of the episode, there's a formula for wRC, not wRC plus. And if you look at it closely, it's really just WOBA minus WOBA scale, or WOBA minus league WOBA divided by WOBA scale. In that sense, then you're really just doing runs per plate appearance, because those cancel out, because the WOBA does equal that league WOBA in that case. So you're just canceling it out. So it's really just runs per plate appearance. So in the ACC, there was 1,162 runs over 9,482 plate appearances. So now that we have that, we'll also multiply it by 100. Add a comma, and then these next three lines are just rounding. So we're going to round WOBA to 3 decimal places. Weighted runs above average, we'll say 1. And then the wRC plus, there's no numbers there. It just rounds it to 0. And then don't forget, we did add a mutate function in here. Again, this will be on my GitHub if you don't understand this part, but make sure you watch the WOBA and weighted runs above average to understand that. Then, just to make it easier on us, we will select a specific subset of variables. So what select does, it just selects specific columns. So we'll say player, school, plate appearances, WOBA, weighted runs above average, and then wRC plus. And then, to be able to sort, add another piping operator to indicate that, hey, we're not done with our code. We will say filter. We'll say PA is greater than or equal to 50, so at least 50 plate appearances, because again, the 2020 season was cut short. And then we will say arrange negative wRC plus. And really what that is, when you put that negative in front, is you're arranging by descending order. So we will run this now, and we can be able to see some wRC plus data. So we'll look into this. There are 29 players who qualified in those 4 specific teams, and Aaron Sabato had a 161 wRC plus based on this formula, a 528 WOBA, 12.7 weighted runs above average. Elijah Cable had a 155 wRC plus, 526 WOBA, 11.4 weighted runs above average. So essentially this is saying that Sabato was better than 61% of league average by weighted runs created plus. So he's better than 61% of Division I and the ACC conference. So this is actually a really cool way to determine some players. So we can go down and see, look through the entire set of guys. But this is a great way to determine a player's total offensive contributions, especially when you compare it to the rest of his team, the rest of the conference that he plays in, the park that he plays in, and the rest of the league that he plays in. So thank you so much for watching. I really hope you appreciate it, and I do apologize for the amount of time that it took to post another video. Kind of some health issues got in the way, but thank you again for watching, and I really hope you enjoy this, and like and subscribe if you want to see more future content, and have a great rest of your day.